Hello, hello. How's it going? Happy Friday. How's everyone doing? Turn the sound off, the music off here. Let's get going. Hey, Fox Shadow. Just in time. Just in time to get going. How's it going? I've been reading about memory owner as an alternative to just the generic iMemory owner interface. Use the actual memory owner class, which is an implementation that exists in the Microsoft Toolkit, the high performance buffers. Seems pretty cool. I've also been reading about span owner, which we might use later on. The Popsky Jam was awesome. Yeah, Popsky's cool. Popsky seems to be most of the chiptune music I have available to me. Yeah, sorry, Fox. We're not listening to music during the stream. There just isn't enough music, is the problem. Smooth, do you have the Twitch and the YouTube opened at the same time? That's hardcore. Nice. I appreciate that. Yeah, let's keep inflating the numbers. But yeah, so we need to implement some stuff. iBuffer. I didn't actually look at this. No, that's not exactly what we want. Yeah, we got to do some stuff around around writing a buffer, but I'm kind of just reading through some of this enumerator stuff. I kind of want to get into some of these high performance enumerables as well, because we do a lot of enumerating. But let's save that for another time. The thing we're trying to tackle today is buffers for data that's too big to fit into a component, like the list of like blocks that belong to a ship, like all the blocks that a ship has. We need to figure out an alternative to that. Can't talk on YouTube. It's on work comp and don't want to sign in. Ah, fair enough. Fair enough. So yeah. So we might end up changing a bit of our chunk implementation to swap iMemory owner with a proper memory owner. But we're not going to worry about that right now. Our chunk process is very different from our buffer process. So let's write our buffer process, and then if we end up liking it, we can use it. Let's get the world over here. I don't think we need to mess with the component anymore. I think we have our components registered. Yeah, we have a block buffer registered. Excuse me. So we need to look at our block buffer. Currently, our block buffer keeps a track of its index. which seems adequate for now. Its bounds. Let's actually reverse that. I actually don't know how smart the compiler is. I'm pretty sure the compiler utilizes a very literal memory layout, or a very literal layout for the values here in a struct. So I just want to make sure we're listing the biggest field first. So we have our read-only and our read-write functions, which we put onto the block buffer, which seems reasonable. And so we can get back a big old buffer of memory here of all the blocks that belong to an entity. We just need a process for creating and maintaining this database of block buffers and other buffers. Honestly, I kind of want to store all the buffers in one go, in one place, and just store them in byte form. There's a number of reasons that will be helpful. So instead of a list of iMemory owners, let's try an actual list of memory owners themselves. We have access to this, right? Oh, do I need to add the Microsoft High Performance Toolkit? Do I not have access to this? Microsoft.toolkit.highperformance. Let's see if I have access to this. I might need to go get the package. Oh, it's not called Microsoft. It's called Microsoft.toolkit.highperformance. I don't have this. I haven't had to do this in Writer. I'll probably just go get the NuGet package. Community toolkit.highperformance. All right. It's community toolkit. Oh, N community toolkit. Yeah, this is what we want. Let's install it. Okay. Now we should have access to this. So is it not this? Is it community? Oh, it's highperformance.buffers. All right, there we go. Hey, Scott. Haven't caught the stream in a bit. Been busy with work. How's everything going? It's pretty good. We've got the whole entity component system all together. We've got queries, so we can, ask for components, or we can ask for entities that have a specific set of components, or that don't. We can be like, give me everyone who has a position, but not a direction, or whatever. And that's pretty good. What we're working on right now is we need a system for storing a large amount of data on an entity, not inside the chunks, so like separately. And our use case is like all of the various little blocks that make up one of our ships. So we're working on that, and we're gonna use some buffers. We're gonna make some buffers, some memory pool buffers here that we can pass around, that we can have as a hold on a reference in a component. But how are you doing? Happy Friday. All these data buffers. I don't know. So we can have this. So we can have this set of buffers. So we need a way of allocating, disposing, getting. We need all of these different things. Because I want to just be able to say get component. Well, how do we have this? How did we decide this? We said game.world.getBuffer index.span. Okay, so we're going to have a get buffer function. It's going to return a memory. A memory owner can actually return a span directly. So maybe we can do that instead of using an intermediate memory. So instead of, we can just do a span of t. Where t is unmanaged. Do that. We could just directly get a span. We would call this like get read write buffer. You just say get read write buffer. We could also have a separate. Well, let's write this one first. Not bad. Just trying to get through some end of year jobs before taking time off for the holiday season. Hell yeah. Yeah, the end of year, beginning of the year period is always super busy for me too. That's why I kind of started late today. I was trying to crunch some stuff out. All right, so to do this, we just basically would say, we pass in an index, and we would basically just say data buffers let's say data buffers index dot span. Cannot be used with type arguments. Okay, so it just wants to, so we need to pass in we need to say memory marshal dot cast byte t, pass in this span. All right, that saves us some effort. So on the block buffer, we would just say and so instead of doing the cast here, we would just say game world dot get read write buffer. Get read write buffer t, or no, block index. Can this be static? No. We're passing in the index. Similarly, we can get rid of the cast. Say get read only buffer, which we haven't written yet, but we will. Block. Okay, that's pretty reasonable. And it's just return. I understand a little bit more about memory marshal, but I'm a little skeptical that it's as cheap as I think it is. But so when I tell it to cast, yeah, it just creates a span. That's just a look into memory. It doesn't allocate anything except the span itself, which is fine. We have to allocate the span no matter what. Might have some platform access issue or platform support issues with this, but I don't really care. So memory owner is pretty cool. It's better than just using a raw iMemory owner, using the actual memory owner type that they've created with this toolkit. It gives us an allocation mode where we actually get we get a piece of memory that's actually the size that we want, and not just a memory that's at least as big as the size that we want, because it might be bigger. We might end up wasting memory. For the chunks, that doesn't matter, I think, because the chunks are always the same size. But I think for these dynamic buffers, it does matter because we might get different sized, we might want different sized buffers here. So I think for these, it does matter because it reuses the arrays when it can. It also shortcuts the need to have a memory and then a span, because with iMemory owner, you get a memory first, which is this heap object that you can store, and then you can get the span from that memory. Memory owner lets you bypass the memory part first and lets you go straight to a span. So that's great. Again, for our chunk system, it's okay that we have the memory intermediate object because that's, and that the memory owner is separate from that memory object because we store the memory on the chunk. And by that I mean capital M memory, not like, the data. Also, buffers are not cleared by default, which doesn't usually matter, especially for chunks, and probably doesn't matter here either, but it's nice that this provides us a way of clearing. We can do a clear on allocate. We can also slice the data, which returns a new instance that wraps just the subset of data we want. And I think that's going to be super useful to us because let's say you're like creating a ship, and so you start working on your ship, you're editing it, or I'm editing it as the creator. And let's say like we start with like 6 decks or something like that, which is the maximum, or 5 or whatever the maximum is. You start with that, and let's say you don't use all of them. You use like the middle 3 or something like that. Then we can just slice out the part of it that we need because each z-axis is stored together contiguously. We can just slice it down to only the data we need, which is cool. And then store that and operate on that. There is a question in my mind about, like, what if there's a crew member? So crew members are going to want to know about the block that they're in, right? They're going to want to know if they're like, they're going to want to know information about the block that they're in. It makes sense. So what do? Do they ask the ship and they get the buffer from the ship and they read through all of that data just so that they can do some operating on themselves, that's horrible. So I think we're going to need to do some kind of synchronization where a crew member can store the block that they're on in a component, but then we have to synchronize that from the actual data that's stored in a buffer somewhere. So we'll have to think about that. But I think doing something like that will end up making sense. All right, let's write this. So we have a read-only span. A read-only span of T. Get read-only buffer T int index T is unmanaged. How do you not know this? Oh, I spelled it wrong. So we return memory marshal dot cast. Oops. Exactly that, but with a span. That's cool. So we've cut out a step. We don't need to get the memory, then get the span. That's nice. We don't need to have these functions exist on every single buffer struct, which is nice. We don't need to rewrite this every time. We just have it on the world. So that's cool. So we can get rid of this. Simplify that. We can actually simplify this a lot. Just change this to be this. Right? We don't need anything else. Oh, you're not a record struct, but you should be. Okay, then we still have to do, we still need these two things. So let's look at our components. So we want to override a couple of things. Well, we want to define an equals function for one thing. And it's going to just be, you're just going to compare your index. And our hash code is going to be what, our index. Fine. Could be our index and our bounds, but I don't know if I care. Oh, we have a two-string implementation now when we do it this way, so that's nice. You can get a read-only buffer, we can get a read-write buffer. So we need to manage the creation and the restoration of these buffers a little bit here. Right now we don't need to care too much because it's all managed memory, but and the memory owner itself will handle the disposal when it leaves scope, which is kind of awesome. So we need a get. So we basically need a similar function to our entity ID. Well, it doesn't actually have to be the same as the entity ID recycling because the memory owner itself handles all of that. We actually just need to add data buffers as needed. So that's like really easy. Do we even need a get next buffer ID? Probably not. Yeah, it would just be get next buffer index. That's like really stupid because we're not using an ID system. So when we say add component, well, here's the trick, I guess. Here's the trick. A buffer is a component. Do we really want it to support add component? I think we do. I think we want add component to support buffers. But if it does, that means we need a catch here. Ooh, are we gonna have a flag that is not? We could have it. We could have something down here at the end, and we could be like buffer is. It would be like block buffer or whatever or whatever. And this would be combinatoric. I don't really want to do this. I don't want to store it here in the flags because that means we pay for every combination. So instead we could say something like this. We could say public flags buffer get is flags dot block buffer. So we can just say this right now. And then we can just add things to this. We would just add things onto this if we needed to. This will just be a flag. So if it has, so if the buffer, we could even do this a little simpler. We could be like public static bool is buffer. Basically this. For right now, this works. As we add additional buffers, we'll want to change that. We probably will include a buffer flag in here for evaluation. But let's just have an is buffer function right now. We can say, so we can do a check here. We can say basically, oh, well, no, maybe we don't need to handle this here. Maybe we have something like this, public void. Maybe we do this differently. Maybe we say like add buffer t, and I'll just copy all this stuff over. Well, we need to define the values first. Maybe what we do is we define an interface at some point. Let's do this. Let's say if value, let's say if component dot is buffer t, no, type flag, rename that to component. So if this component is a buffer, then what we'll do is we're going to say value is value with, we probably shouldn't do that. I like never assign to a function parameter. I feel like that's not something that we can do or should do. Can you just do that? Is that actually not that big of a problem? With index equals data buffers dot count. Oh, I guess we don't know that the value is t, or the value has an index, do we? So we cannot do that. Okay, that was dumb. Yeah, so we need a public void add buffer. So we just need a parallel process that basically mimics this, but with buffers. I was hoping we could do add component. I don't really want to do a check where we ask something like if component dot is buffer. Maybe we should have this. Is buffer value throw new argument exception. Oh, we don't pass value, we pass component. Throw new argument exception. It would be like component is a buffer, or maybe it's something like component is not supported for add component. Use add buffer instead. Is a buffer which is not supported by add component. Okay. I think that's a little stupid to have that check every time, but I think that'll save me some pain far down the road when I accidentally try to pass a buffer to add component. Because that would be a legal thing to do. Like, there's nothing I can really do to stop someone from doing that. And by someone, I mean future me, who's a piece of shit and is going to try stuff like this. This is going to have buffer in the name. All right, so we're going to basically do the same thing. Pretty much exactly the same thing. I think I need an interface. Buffer. All right, we're going to make buffer components here. Where is the block buffer file? Oh, they're in here for some reason. Crew buffer's in here. That's not right. Where's block buffer? Okay, block buffer is here. I feel like every day we have a word that we say so many times it just starts to sound insane to us. It's usually chunk. Historically, it's been chunk. Earlier this week, it was query, and now it's buffer. It's horrible. Pretty much any small word, you say it enough times, and you're like, this doesn't make any sense. You're like, this is madness. So we're gonna need like an I buffer, which I don't love. We should. There already is an I buffer in the high performance toolkit. I'm pretty sure. Pretty sure I was just reading about that. Yeah, there's an iBuffer T. So let's not define our own iBuffer T. We could say iBuffer data. We could say iBuffer component. We could say iComponent buffer. I think that's fine. Well, wait, hold on a second. Well, does this work? Can I I just require that an iComponent buffer has an index field, and that's all we do with iComponent buffer. So we say block buffer is an iComponent buffer. And so when I say this and I say so let's do it here. So when we only reference value once, right? So here, instead of saying value, we say value with index equals data buffers dot count. So why does this not work? Cannot resolve symbol index. Oh, I need to say where T is an I component buffer. Buffer, not I component. You stupid bastard. There we go. T is an I component buffer. Oh, can we not do this now that I've defined this as... Really need to do it like this? Maybe this isn't the way we do this? Thought this would be fine. Because we don't want to box the struct. Yeah, this should be fine. This shouldn't result in boxing. But I can't use this I can't use this semantic here. The cool value with this. Maybe this isn't the correct way to do this. Maybe we say something like variable like indexed value equals value with this deal. Am I allowed to do that? Oh, unmanaged. Oh, can we not do that? Unmanaged high component buffer. Oh, okay, I gotta switch to an explicit constructor. Or not, I don't need the constructor, I just need to define the actual... Define the getters and setters here. I should define... Okay, hold on. Let's rename this file. You're an iComponent buffer. Specify that you're unmanaged. Is that doable? I guess I can't do that. I can just say that T is both unmanaged and an iComponent buffer. And then here, it's still upset about this index. It doesn't look like we have to do this, though. So index. Property without setter or inaccessible getter, or without setter or inaccessible setter cannot be assigned to. Really? Do I need to say init? Do I need to add an init? I say like init. Okay, so yeah, so I need an init if I want to be able to do that. Similarly, I need to define that here. So this counts as an implementation? Yes, it does. Beautiful. All right, so now we can make guarantees about the buffers. Very clever that it understands that this is like not being used here. Well, I guess it doesn't matter. All right, so we can now add buffers. And the only real trick is that we're pulling the index from the data buffers.count, which this is a little dangerous in some contexts, but in our like single threaded, like linear context, we don't care. Maybe we head it off at the pass and like define this as something. Say get next buffer index. It's kind of stupid, but it would let us change the implementation later without having to think about it. Okay, so we can add buffers. We probably need to do some additional things here, huh? So we're doing all of that. So after we do all of that, let's say data buffers. Oh, let's just say variable index equals get next buffer, integer index, index equals index. We'll say data buffers next index equals memory owner dot allocate memory owner byte. So memory owner byte dot allocate. So we need a length. So the size of this is here's a fun thing. So we say get component. So we say component dot size. Do we say component t dot size? How do we get a component size? I know I've done this. I know I have a process for this. Where do we actually have to do it? Let's look at the archetype, maybe. Archetype probably tells us how we do this. Or maybe we do it composition.get largest component size. No. Maybe the composition knows. Component.types.size. So component.types flag dot size. Okay. Component dot size. Size is unsafe size of t. Beautiful. We need a buffer to tell us. We need to add something onto the buffer. We need to define another required function for iComponent buffer. It needs to be able to give us its size. And what do we need to know to determine that? We need to know its bounds, which we have. Well, okay, no, this is implementation specific. So we need to require that we have a size. We need to define a size function. Or we could just make it a property, I guess. So it would be allocate value dot size. Size. It's size in bytes. So I guess we just take size. Let's just store the size for now. How about this? What if we say, oh, let's instead of calling this size, let's call this length. Makes sense that a buffer should know how long. Well, span that we get back actually knows how long it is. So we actually don't need to define that. So what do we need to define? We need to know, its size. I guess we do need to know something about the length of the buffer. So we do need to store this. Then here we would say ABC public integer length. Its length is actually its bounds dot x times bounds times y times bounds times z. I guess this is a function. Auto complete is a little too aggro sometimes on this. We don't need an init. I don't know why an init showed up here. Just need this. So if they ask the length, we just give them the bounds.x times the bounds.y times the bounds.z. This is implementation specific. So we just do that. Easy, GG easy. Okay, so here you would say value.length times component dot types component dot size. Yeah, that's it. That's its size in bytes. It's the length of the buffer times the size of the component in the buffer. Easy. Easy. Man, the fact that we're storing all of our stuff just in bytes is going to make serializing this and deserializing this so easily, because we don't store it by its type. We store almost all of this game data just in pure byte form, and then we interpret it when we need it. It's kind of cool. Kind of stupid, but kind of cool. I'm gonna call this ID just in case it. We'll call this like next slot. I don't know, whatever. I guess next index is fine. Might change this to an ID. I don't see why we would need to, but who knows? Yeah, who cares? We're only doing this in one place. Let's forget about this function. It's easy enough to just say the next index is the current count of the data buffers. We'd say data buffers dot add. Oh, well, if we do it this way, we don't even need to store this part. We can just say, we can just throw this down at the bottom here. Get rid of this next index thing, and then just say, go back to what we had in the beginning. All right, we got ads. We're in the midst of some ads. Got 3 minutes. I might go grab a little snack here. Come back in 3 minutes. I really appreciate everyone hanging out here on a Friday. Be right back. All right, I'm back. Thanks for hanging out. I got one of those little, sliced myself up a little apple. Got myself a little bag of trail mix. We're good. This is the wrong scene. I had a cinnamon roll for breakfast, which was delicious, but my body is like, is that all? Is that all we're eating right now? We're not having something else? Yeah, exactly. All right, so we can add our buffer. It's beautiful. We will defend against adding a buffer accidentally as a component. Beautiful. We have a get component. We should probably have a get buffer as well. What does that give us? Oh wait, no, we already have that, don't we? We have get read only buffer and get read write buffer. And we have get component, which would give us the buffer component itself. So that's all set. I forgot that we already did this. Yeah, exactly, Scott. You got to keep up those nutrients. You telling me my balanced breakfast of one cinnamon roll didn't set me up right? I want to test my buffer, but like, what's the test? Like, we can get rid of this old test. Let's just make let's make one entity. Let's fill up a buffer with some data, and then let's get the buffer back. I guess, I don't know. So we'd say world dot create, or we gotta say game world create entity. Composition is gonna be, should I have to define the entity ID when I make an entity? Like, no, right? Like when I'm building these and I'm doing like component.flags.position.direction. I should never have to say entity ID, right? Like it should just add it. But when I'm looking for an entity, I don't know. Let's keep it for now because I need to think about the consequences of changing that. Let's just have a block buffer and nothing else. Did I just call this blocks? Instead of block buffer? I don't like including the structure of something in its name, but I do it. I do it anyway because sometimes it's the best option. We'll say block buffer. Then it's very clear that it's a buffer. A lot harder to make a mistake. We're going to say variable. Well, we can say entity equals, because this should return to us an entity ID, right? All right, so we'll create our component. We'll create our entity. All this stuff. Wait, why do I pass a composition to create entity? It's because I want to be able to do it all in one go, right? But is the system smart enough to do that? I feel like it isn't. I feel like I didn't. Oh, it's because we need to select an archetype, put it in there, and we reserve the component slots, and then we set that. Okay. So what we do is then we say, then we just set components. Right. Okay. So then we'd say entity, or we'd say game.world dot set component entity component dot flags dot block buffer. Then we'd say new block buffer. We'd say, let's say the bounds are utility dot max ship extent. And then let's actually make this optional. We're not actually going to define the index by default. Okay, so we're making a block buffer of a certain size. And then let's just go through. Well, then we say variable block buffer equals game.world.get read write buffer block. And then we'd say game.world.get component block buffer entity. Oh. How do we get a component? We have more of these. Okay, entity ID and type flag. Entity ID block buffer. So we get this component and then we just say index. We need to get this up here. We need to say variable. Okay, so we say block buffer. So the block buffer is actually this function. We say entity. Type arguments of method T, get component T, cannot be inferred from the usage. Oh, I probably need to say, I need to say, really? Wait, do I need to imply also list the T? Oh, I hate this. This is maybe the worst part of my system, is that I need to define the type and still pass in the flag. Kind of unacceptable that I need to do both of those things. Okay, so now we actually need to get the actual buffer back. So we'll say, we'll call this block comp. Call this block data. Block data is going to be game.world.get read write buffer for a block using the entity. So this will be a span. So we'll say for I guess it doesn't really matter. You could say for I equals 0, I is less than block comp dot length I plus plus. And then for each of these, we do that. So we could iterate through this, and then like we could have a single loop and like do the thing where you derive the x, y, and z. So you would say z, you would say, why is this block? Oh, because I'm not using it. We'd say z equals, well, we don't want to calculate this every time, do we? So let's just do it. Let's do it the normal way. Let's say z is less than block comp dot bounds dot z, z plus plus. We're gonna do the 3-dimensional nested for loop here. Okay, I just did z and y, and your idea, writer, was that we're gonna do x, or we're gonna do I next and not x. Okay. All right, so we got this. We're iterating through everything. We go z to y because everything is organized this way. So we're gonna write in the data here. We're just gonna, let's just record the actual coordinates here. So let's just say block data x plus y times block comp bounds dot x plus dot x plus z times block comp dot bounds dot y. So that's our collapsed coordinate system there. Kind of like writing this in reverse, but I think it's fine. And we just say this is going to be vector 3i Oh, well, wait, hold on a second. We actually, I have to keep in mind what's actually stored in the blocks. Uh, we actually don't store, we actually only currently store this here. So, let's make some operators. What order do I normally do that in? Okay, that order. This is going to be meaningless very soon. Oh, he wanted to write the whole thing out for me. Yeah, do that. Thank you. Do this. I love this. I love that I have to import myself. Block.forms. That's really stupid. It's time to crack open this trail mix here. How's everyone doing? Anyone got plans for the weekend or anything? It's gonna be raining up here. I'm not gonna do much. New Helldivers enemy has arrived. Oh, like the Illuminate or whatever? Like the new faction? Oh shit. Okay. I can be down for some of that. Yeah, we might need to do some democracy. That's true. Let's set the form for odd blocks to be 1 and for bulk blocks to be 2. Or even blocks to be bulk. Let's just do that. Let's just do like in every other, because we're just checking to see that we can store and load the information correctly. We don't really care what's in here. Oh, in which case we don't actually need this XYZ shit. All right, so this will just fill the block with information here, just arbitrary information. So we also need a print buffer function. We have print entity, we need print buffer. Oh, we almost need like an enumerable one. I don't like that. We're just gonna hack it. Eventually I'll want some kind of print buffer function, but we don't need it right now. We can just we'll just print the entity and then we'll say for, and then we'll just do another for loop. Let's just see if we're able to store and retrieve this data. Well, what we should do is actually we should do this in a separate pass, but who cares? Let's say block right. Let's just say right block. And then let's just get it again as a read block. Just want to test as many of my functions as I can here. It's just gonna be read block I. We're just gonna have debug dot write line read block I. All right, I'm ready for the errors. Hit me with these errors. I'm not even gonna check this to see if this makes sense. Oh, I didn't add the buffer. Okay, I see what we need to do. Excuse me for the eating sounds. I'm trying to get it to cut out with the noise canceller, but it doesn't always happen. Okay, so we can't just create an entity with a buffer right now. We'd have to add an additional check. All right, I'm gonna run this again and it should fail. I'm testing to see if my add component catch for trying to add a buffer works. All right, we threw an exception. Love it. Love to see it. Okay, so we were able to catch the usage of a buffer in add component. That's good. That's what we want to see. So we swap this over to add buffer instead. Okay, no errors. Let's check the printout. It's weird that it's telling me the form and the form, like it's listing the form twice. But other than that, it's working. It's maybe not quite as many as we should have. Block buffer, so we got our entity, we got our block buffer with bounds 883. Index, ooh, the index should not continue to be -1. Oh, but then we have bounds 883 and index 0, length 192. Oh, I was not expecting that property to print itself out, but that makes sense that it does. Okay, so our parameters are becoming like backing fields or something. I don't know. This is wrong. This is not how this is supposed to work. Why don't I run into that same problem like over here? Oh, because these are the only values. I see. So I need to get this out of here. So we're gonna take that out of the parameter thing. We're going to remove this here and rename this to bounds with a capital B. And that should resolve our problem. Shouldn't have any more duplicates up here. And everything should read out correctly. Yeah, bounds is 883, index is 0, length is 192. Love it. You know, I'm curious about something. So if we go to our print entity deal, which actually is in the archetype, I just want to clean up a little awkward thing that I have here. So if we go down here, so is there a way, string builder dot remove? So there's an append and there's a remove. Can I just remove whatever's last? Like whatever the last. I just want to remove the very last character. So I would say string builder dot remove string builder. Oh. JetBrains seems to know exactly what I want to do. I just want to remove the comma when we run out of properties to list. Just clean that up a little bit. Pretty fancy if that does work. Oh yeah, it works. Look at that. I'll remove that space at the beginning here. Oh, but it's here. Don't think I can remove that. Oh, I can do it this way. I can remove it there. and then add it here. And then at the end here, I say -2, 2. This is really nitpicky, but I enjoy this kind of stuff. Yeah, there we go. I like this printout of the entity description. It's readable. I'm using different kinds of braces to describe each thing. So a component's fields are enclosed within curly braces because that's like standard, I guess. And then I've enclosed the component itself in parentheses. And then I've enclosed the entity overall in square brackets. I guess I don't need the square brackets thing. Unless I was to dump this all somewhere else. Yeah, so maybe we take the square brackets out. Or we use them inside here. The only other option is to go back to using squirrely curly braces here. I'm just kind of having too much fun. Fusionist, hey, how's it going? How are you doing? We're messing around. We just implemented buffers, data buffers, and we're just kind of having a little fun with our debugger tools. Yeah, let's just go with this. This seems fine. Actually, I don't love this. And go back to parentheses. What I had was good enough. What I had was fine, and we're just going to go back to what I had. There we go. Happy with that. Let's move on. Chilling today. How about you? What are you buffering? Oh, so we have our entity component system all set up. So we have entities, we have all their components that are stored in chunks. But the problem is some entities are going to want to store big buffers of data that we do not want stored in the chunks because basically our chunk utilization is tied to whatever the largest component is. So this is essentially like a chunk independent storage for an entity. So an entity can have these big buffers of data that they can reference in a component so you know that it has it, and then just store the buffer somewhere else. And it's stored using a similar process to our chunks, so it's pretty fast. Should be pretty performant. It's just memory owners and spans. And we did that. We just need to clean up our little block. I keep messing up how record structs work. So this should be here. Don't need this. How are you doing? Ready for the weekend here? Yeah, all right. So we're basically alternating even and odd. So 0 is a bulk, 1 is a deck, 2 is a bulk, 3 is a deck. So yeah, we're storing. It's pretty cool. We have all of this data stored generically. Same thing with the chunks. Like all of our data when it's stored is just stored in raw byte form, and we just cast it to whatever we need, to whatever it actually is when we're using it. So it's kind of fancy. So I'm kind of looking forward to figuring out our serialization process for this because I think it's going to be easier than not. Although there is one thing here, which is that we have this list of memory owners here. No, that's fine because the component knows where its data is, and if the component still exists when we serialize it, it'll be able to find its data as long as we store all the data and give it back to them. Beautiful. Love this. The disposing of this data is a little trickier. We're going to need like a free buffer function. Maybe, maybe not. I mean, we should have it because component entities are going to be created and destroyed. And so we want to, this is for now all managed memory. So we can just delete the memory owner from the list. The garbage collector will figure it out. We'll get more precise with that later. I just don't want to get bogged down to that right now. So what we should do is say something like free buffer. That should be a private function. Oh shoot, this is like entity IDs. Damn. Okay, wait. We have to actually think about this. What if instead of having an index, no, we can't do a dictionary because a dictionary, unless we make something like a dictionary that's keyed by like a combination of like an entity ID and a type, because it can't just be entity ID because an entity might have more than one buffer. We can't do what I do with the entity list, which is when you remove something from an entity list, you just fill in that spot with whatever the last entity is. Because then you need a 2-direction lookup. Oh, maybe that's just what I do. Maybe I just do the same lookup process that I have. Okay, that's fine. We're implementing buffer IDs. That's what we're doing. The only other real alternative would be some kind of dictionary thing, which if we're going to do a weird dictionary anyway, we might as well just do this thing that we already have. So we're going to have data buffers, and then we're going to have dictionary. Dictionary is going to be int to int, like this one down here. Int to int. I need to come up with a better name for these things because this is basically going to be buffer index map, because that's what we've called the other one, the entity index map. Let's swap these two. Let's just call this buffers. Calling it data buffers. That's like really stupid. That doesn't tell us anything. You shouldn't use names like data unless it's a meaningful distinction. Like buffers versus buffer components. It's like a meaningful distinction. I guess buffer data versus buffer comp is a meaningful distinction because you have a component and that's just the reference to the buffer. But we're just going to call this buffers for now. So we need a similar process to the way we create entities. So we create an entity here. So we should have a private. What do we want to return? Buffer ID? Okay, time to make a buffer ID. That's not a component. Unless it is. It's not. It will be structured basically exactly the same as an entity ID. Should have just copied the file. Oh, I keep forgetting to add the domain names to things. Namespace di.ecs. Oh, okay, it's already got it. Namespace, not domain name. Fusionist, but what if it is? There's a fun alternative world where we were actually going to have buffer data as like its own entity. And that would have been cool and super feasible. So instead of storing all of the blocks for a ship on a buffer, you would basically have the blocks as individual entities. And then one of the components of the block would have been the ship entity itself, right? It's basically entities as components, because then we could query, we could say, give me all of the blocks that contain this other ship entity. So like every block that refers to this ship entity. And that would have been super cool. And if we were better and probably not working in C#, we could have done that. Mainly if we were better. I don't want to malign C# for this. It would have been easier to do maybe in like C++, but we're doing some weird stuff for accessing generic component data, and one of the core tenets of that is flags, type flags. And you can't use type flags if you just have entities as components. Like you no longer have a finite number of components. You have an unlimited number of components if you have entities as components. So we didn't go down that road, so we're exploring this alternative. And it'll be fine. It'll be fine. So the buffer IDs we're going to recycle. The buffer themselves, that's handled by memory owner. We don't have to worry about recycling those. But the IDs we do need to recycle. So that's what we're going to do. Is there a high performance hash code? I need to read more about these various high performance methods. I added it so I could use memory owner, and I'm like looking at all of these different options, and they're looking pretty good. All right, so now we have a buffer ID. It's indistinguishable from an entity ID. Really, structurally. But what we're going to use it for is different. It'd be kind of cool if we had buffers as entities. But it's also not useful, so we're not going to do it. It would just be like an additional indirection. It'd be like you'd need to get the buffer entity and then get the buffer from using the buffer entity. So we're basically doing the same thing but with fewer steps. We're just having a dictionary that matches them, that maps them. Yeah, you've been using whatever the default hashing is in C#. No idea if it's good with strings or anything. Oh yeah, don't use the default hashing with C# generally. For all of my record structs, I just override with hashcode.combine. Hashcode.combine is cool. The default object hashing implementation is not cool. It is not cool. If you can avoid it, don't use it, especially if you can just easily override it. Hashtag.combine can take a bunch of different values, so you can just shove all of the unique and most importantly unchanging values. Just throw it in a hashcode.combine. It's easy. Like our buffer ID just combines the index and the version, which will never change because these are all read-only record structs. All right, so noted for the day that you code anything large scale. Yeah. No, you're right. Most of the time it doesn't matter. And actually C# is pretty fancy because I used to be worried about hash collisions, but C#'s dictionary is nice enough that it just does an equals comparison. If there's like a hash collision, like I think even if there isn't a hash collision, it does a comparison, but I'm not sure about that. But yeah, you never get the wrong object out of a dictionary because it just compares the equality of what you passed in for the key and like what's stored as the key. It's pretty cool. Pretty cool that it does that. So yeah, who cares? Yeah, it sounds very funny not to do an equals check. I don't know. There's stuff people do that's pretty crazy in the name of like, avoiding unnecessary checks. You learned about hashing in dictionaries with Java, which does the same thing, I think. Yeah, well, that's probably because C# is like Microsoft's Java, right? So they're like there's like a lot of overlap, I think, in terms of like the principles. Okay, so we just need to recreate some of our create entity stuff, and to an extent, we need to do the same thing with a buffer. So we'll say private buffer ID, create buffer ID. Oh, we need a live buffer count. Maybe it's like active buffer count, something like that. Live doesn't feel like the same thing. Live doesn't seem, and also active buffer is the same length as live entities. You love to see it. You love to see that kind of a variable alignment. Should put these somewhere else. Split these up by some degree of organization here. Take all the good ideas. Yeah, exactly. What have you been up to, Fusionist, in terms of like in dev world, in dev land? How's it been going? Oh shit! Here comes high fiber high fiber combination, letting us know about the cheap viewers. I added a photon torpedo sound effect for when I banned people, and I'm very pleased by that. Oh, cool. Yeah, we showed him the door smooth. Uh, that's awesome, Fusionist. If you're able to, also no pressure, or if you're inclined to, I do invite everyone who's like an active dev to the Discord, just because I love when they share their work there. I love seeing the stuff people are working on. We have some pretty cool people doing some pretty cool things in the community. But no pressure. I know I'm in too many Discords. Hard to keep up. If you're already in the Discord, I apologize for not realizing. Oh yeah, no worries. I don't advertise it very often. It's really small. We're still a really small community. We haven't even been streaming for a year. So here's the difference here. So this is a list of entity IDs. Entity IDs. This is a list of memory owners. I think that's fine. I just need to make sure. I need to keep in mind that these are not the same things. So this is like buffers.add buffer ID. No, we don't add buffer ID. We add a New memory owner. Where am I doing that right now? Okay, we're doing that all in here. We need to not do that here. So instead of this, it needs to be like this. Oh, shoot. We actually need to know the size of the thing that we need here. So I guess we need to know the length of the buffer. Let's just add a blank thing, I guess. Can I do that? Can I add an empty memory owner? Is that an option? Empty. Oh, that's so sick. You just clean up your list too? Yeah, I didn't delete many, but I realized that there was such a thing as Discord folders. So I've started throwing all my Discords into folders, which helps a lot. So I can go in and check in on like a whole group of Discords when I have time. I can be like, I'm going to check in on these Discords, and they're all like, boop, right in a folder. So we're going to add memory owner byte dot empty. Oh, method delegate or event is expected. What? Oh, it's a property. The running gag about Discord is that they'll implement features 5 years after popular demand. Oh, yeah. That's what you got to do. Honestly, that's the scariest thing about solo or even just indie game development. That's like the curse of like game development in general is that like whenever something's popular, if you think you're going to do something when it's popular, you're like, "Oh man, this thing is so hot right now." Then you start working on it and then you release it 5 years later, it's no longer so hot right now. And it's like kind of scary. It's kind of why you got to do your own thing and just get lucky. Or you got to be very fast. You got to be real fast on the iteration times. Yeah, it's like hero shooters. There's like a bunch of hero shooters coming out right now, and it's like I think hero shooters are like good. I think we're like good on hero shooters. But we weren't like, 7 or 8 years ago when people started making them. Yeah, being overshadowed at times sucks, and there's really nothing you can do about that, I think. There's some people that have done some pretty clever things, like the person that like released their indie game like the same day as like Starfield or something, because none of the other big players were like anywhere near that release time, and they were like, my game's totally different than Starfield, and they did really well because no one else was releasing then because people were too afraid to compete with like a big game like that. It's funny how that stuff happens. Buffer index map add. Oh no, we just say buffer index map buffer ID dot index is right, buffer ID dot index. This is the same. This map matches only when it's initially created. Return buffer ID. Okay, so that's creating a buffer ID. Easy. We have ads starting like now. So I'm just going to keep doing this. I'm going to keep working on creating our buffer ID. It's not going to be anything particularly exciting. It actually goes in the opposite order here. All right, what do we need next? So we have our create buffer ID. We've got our get next entity ID. We also need a get next buffer ID. So if active buffer count is less than buffer IDs, or it's buffers.count. If it is, then we recycle a buffer ID. Otherwise, we create a buffer ID. So if we have any buffer IDs available, we'll do that. Otherwise, we create. So here's the recycle entity ID. We add our own cycle buffer ID. We could technically do this like a different way, but it's so similar to our entity ID routines that like I just want to not think about it very much. So it's going to be, okay, here's the part where it's tricky. And here's the part where it's actually kind of different. So here we just get the entity IDs at the count. So we need to do that. We need to do that for a number of reasons. Because we need to compress the list of buffers. We don't want to have inactive buffers. We don't want this list to grow indefinitely. If a buffer is not being used anymore, we want to get rid of it. The problem is we're not storing the IDs anywhere. Maybe I also need to store the IDs. I really don't want to do that. Store the IDs and the buffers. I guess I need to do that. I need to store them somewhere. I mean, I can just store them as the keys. Oh, but they're not being stored as they're not being used as the keys of the dictionary. We're just using the index as the key of the dictionary. Why are we doing that? Is it so we don't accidentally just keep adding things to this dictionary? I could do this a little differently and maybe simplify that. So what if this was a dictionary of buffer ID? So it was keyed by a buffer ID and it mapped to one of these to one of the buffers in the list. I could just call it buffer map. All right, we're going to try this here, and if we like how this process works, we might change up the way our entity ID system works a little bit. No, we don't need to do that. Don't need to do that. This is where the systems kind of start to diverge, I think. So instead of mapping the buffer ID.index, you just are mapping Okay, so it's this. So buffer ID dot index, because the initial index is where we're going to put this. Let's call this the buffer map. So the buffer ID, so if we're recycling a buffer ID, what do we say? We say like, here's the thing. Here's the thing. We have a version number in the buffer ID, and maybe we don't need that. It's supposed to protect us from like accidentally, in the context of the entity ID, it's supposed to protect us in the context of a stale like lookup. And that sort of thing could totally happen here because I was talking about storing references to buffers directly on things to save us some of this time. Maybe we don't do that. Because a buffer basically, all we're really doing is we have a two-step index kind of thing. We have, here's the index of the buffers that we're actually using. And then here's an index of like IDs that we've assigned so that you can have this ID. This ID is always valid. But the index that the ID maps to might change as we're like swapping things out. So the ID needs to be always valid. So it makes sense to have a version number because we reuse the indexes in the ID. We reuse the ID index just so we don't run out of IDs eventually, which I know is unlikely, but this is just like a normal way people do IDs if they're not using like fancy unique IDs. It's easy to just have two ints, like a version and an index and a version. The problem is we're not we're not storing these anywhere. So I think we do need to store them, which is unfortunate. Maybe we don't. Maybe we don't care. Maybe we don't care. Maybe we can use a short for the buffers. I want to keep them to be, I don't want our buffer IDs to be 64 bits. Because basically, I don't want a buffer to really need to store, I don't want a buffer component to need to store more information than like a vector3 and like its index. So if we can do this without a version number, great. We just store an int. Let's try to do it that way. And if not, we can be ridiculous and have a short index and version. What's the largest number a short can represent? 32,000. Yeah, if I have more than 32,767. Oh, and that's negative. Oh, so if I had a U short, it would be 65,535. Yeah, I feel like if we have more than 65,000 buffers, we've run into some trouble. But the better thing to do for what we're working on right now would just be to have an integer index that we can use. So the end. I just need to think about the entity IDs thing because it already works. I set it up. It's just stuff leaves the context of my mind so quickly. So for entities, we have a list of entity IDs. It's beautiful. Oh, I'm going to bring up a visual aid. I think that'll help me. I think this is the right page. Where's the entity thing? Oh yeah, so it's just a dense array, sparse array thing. So we have our dense array and we have our sparse array. So our sparse array is the dictionary that we have, the entity index map. And that just takes an index from the entity IDs thing. And that takes a stable index and then maps to the unstable index, which is where the entity actually is in the dense array, because we move things around the dense array, but we never move things around the sparse array. And we increment the version number just to make sure, just so we don't accidentally refer to a different thing as the same thing. I feel like he did this on a different page somewhere too. So if we have a dense array of buffers move around. There's a sparse map. So we know, so in the dense array, whatever the count is, we know that index is not being used. So if that index is not being used, we can take that spot in the map. I guess we would take any spot in the map that's not being used, but how would we know that? How do we do this recycling? So we just take, so our entity ID is, okay, so in the dense map, we just take the ID that is dead, the first dead ID that isn't being used anymore. We increment the version number. We reset this here. We plug that back in the dense map. And then in the sparse map, we take that ID's index, because we know that index is not being used, and we point it to the new temporary, the dense index that maps to the sparse index here, or that this sparse index maps to. Okay. Okay. So I don't want to think about this anymore, so we're just going to do the same thing. And we're just going to add an additional list, which is the buffers. And the entity ID or the buffer ID index is just doubles, or no, the map. So the map here maps to the actual buffer. The buffer is a class, so that's just a reference. I feel like we're ending up with like a weird linked list thing here. And it's because the entity ID thing works because the dense array is just an array of the entity IDs. But this list is a list of memory owners. And it doesn't have the ID in it. I guess actually all we're doing is we're implementing the entity ID system, and we have an additional list that uses, so we basically just have two different dense arrays. And we do that so that we can map, so that we can, so that we can go back and we know like, okay, this memory buffer is not being used anymore. What is the buffer ID that is associated with this memory owner? Okay, let's just do that. We'll probably come up with a better way of doing this at some point, but I feel like there's a better way to do this. But it's also Friday and my brain isn't really working. Okay, I really want to be able to do this with just a single index. That's like what I want to do in my bones here. I think I can do it. I think if I don't care about version numbers, I can just do it. So when we create a buffer, so let's rewrite this like this. So we don't actually need to create a buffer ID if we do this. We would just get the next buffer index. I feel like there's a reason we're doing it this way. I just don't want to. I mean, it makes sense for entities, and I guess if I really want to treat them the same, I should just do it this way. But I kind of want to be lazy. Because honestly, the buffer has a lifetime that's linked to the entity. Like a buffer does not continue to exist outside of the entity. So maybe we take advantage of that. Oh, I wasn't going to do that because an entity might have multiple buffers on it. I mean, I could have a dictionary of dictionaries. That sounds kind of terrible. Or I could have a dictionary of lists, and the index of the buffer is actually just where in that list it is. That's maybe the way to do it. Just have a dictionary that's keyed by an entity ID. We just delete that whole entry. Or what's more likely, we go through and dispose of those memory owners. Maybe that's how we can do this. Maybe buffers is a dictionary with an entity ID key and a memory and a list of memory owners. A lot of greater than signs. Then we don't need a lot of this. We don't need a lot of this mess. And if an entity gets rid of one of its buffers, then we can play around synchronizing it. Oh, that kind of sucks though. Maybe we have like a buffers class that we make that we make one for per entity in here that needs the buffers, and I don't want to do it this way. This is very quickly moving away from my fun, all the buffers are stored in one place thing. It's very quickly moving away from this. All right, I think we just eat it. I think we just do the buffer IDs properly, like the entity IDs. Buffer IDs actually have shorter lifetimes than entities. Like an entity might go through multiple buffers of the same type. So I don't think there's an easy way to map the two to each other. And then we just got to decide how we map the actual buffers to the IDs. Or, I mean, I guess that's what the buffer map does. I guess the buffers and the buffer IDs are in the same place. And the buffer map links to both of them. So we just have a little additional, we just have some additional management. The only other thing to do would be to like create a buffer object that stores both. Kind of the only other thing we could do. There's already a core library buffer, so I don't want to just call it buffer. I don't really want these to be separate lists. So we need to make a little buffer object. Call it a byte buffer. I don't want to think about this a little more. So Got this big list of buffers, memory owners, classes. We want to map to the buffers. We want to keep the buffer list tight. I guess the requirement to keep the buffer list tight is kind of like misguided. Or like, we could just do something else. We could do like a dictionary. We could do like a buffer dictionary. Which that could at least just be indexed by an integer. I mean, it's still a little scary because you might get the wrong buffer back if you have a reference to it. But how do I avoid that with the entities? I don't really understand how I'm avoiding that with the entities. I guess if you try to get back an entity and the version number doesn't match, that's just great. Like that's just handled. Is it handled? Like what here's my get entity. Where's my get entity? Oh, I don't have a get entity. I guess get entity is meaningless because you would need to pass the entity to get the entity. So you would get the component, you pass the entity. Cleaning up some stuff that I'm noticing while I'm looking around as I kind of mull this over. Oh, okay. The entity indices on the archetype protect us from accessing entities that don't exist, right? So yeah, I guess we just implement the buffer IDs thing because it's like a separate problem. The whole like having a buffer ID system is its own thing. And then accessing the buffers using those IDs in a way that's safe, it's also its own thing. So this doesn't need to be a list. I don't know why I insisted on being a list. It can just be a dictionary tied to a buffer ID. Doesn't need to be this whole thing. The buffer IDs and the buffer map and stuff, it needs to be the same as like the entity IDs thing. That part needs to be the same. But then this actual buffers list, this is its own thing. This could just be the easier way to do this is to just have it be a dictionary with a buffer ID, key, and a memory owner value. Great, beautiful. So we get the safety of the entity ID. Only bummer is that we need to put a buffer ID on the block buffer, which brings its size up to like, you know, pretty big. That makes it 5 integers worth of data. But I guess we just eat that. We just don't care. We're gonna have components that are bigger than 5. And if you're a ship entity, which is the only thing that's gonna have these block buffers on them, probably. Actually, I don't even know if that's true. But if you're something with a block buffer, you're probably got some big components on you. And there probably aren't too many of you. So yeah, we just eat it. So we're gonna turn index into a buffer ID. Gotta update iComponent buffer because you have some demands of us here. Should be negligible in the grand scheme of things, I would imagine. Yeah, you're right, Scott. There's that like sweet spot of like, it's great if like, you know, it's just 4 ints. 5 just feels kind of gross, but it is just a feeling. You're right. It's like, it doesn't matter. It doesn't matter. Thinking otherwise is premature optimization. Is there an index type class? Struct? Oh yeah, of course there is. I've used it. It's good. I don't want to rename block buffer to just be blocks. Same way that crew would also be a buffer, probably. Let's just get rid of the crew buffer for now because we don't care. And in the flags, we need to fix this here. So it's just going to be blocks. Broke some stuff. Okay, so I need to create a buffer ID. So now this is buffer ID. So it's value with buffer ID equals get next buffer ID. So that's nice and clean. So when we add a buffer, we just get the next buffer ID. And then when we add buffers, it's, oh, we just need to store. We need to store this. Variable buffer ID. Get next buffer ID. We need it down here. We need to add buffer ID as the key, the memory owner as the value. Actually, will that work? I don't think, well, thinking about the case of just the raw create entity. Create entity can do some wild shit. So create entity ends up reserving slots on all the chunks. If it ends up reserving buffers, it like needs to do that. It should be something like composition or component dot flags dot entity ID. Like when I get a composition with a create entity, it shouldn't need to include entity ID in it. That should just get added. Because obviously an entity has an entity ID. I probably need to check for, are there buffers? Are we creating an entity with buffers? And if there are, we need to do some shit. Yeah. Similarly, if we destroy an entity that has buffers, we also need to do some shit. Okay, so that's buffers, buffer ID. I need to add some safety to these various things. Maybe, maybe not. Like, you should never reference something that's deceased, but you very well might. Like, you could be like imagine you have like a targeting system and you're like, this is my target. This was my target last frame. I'm try to shoot him. Try to hit him this frame. And then you're like, let me get the position of this target. And the thing is like, that target doesn't exist anymore. That might happen because maybe you blew up the target and didn't notice. So yeah, I think I need to add safety. I need to make some stuff like get component and get buffer tolerant of failure, or I'm going to have a bad time. All right, so I'm just adding in all the buffer stuff here. So now we have a buffer ID system that's identical. Okay, it's not this. Buffer IDs. Maybe we do this part first. Can we do this part and then just call add component? Instead of having all this code written twice, which is like bad form. And you would just say T value with buffer ID equals buffer ID. You don't need the T. You just say value with. Same way we just say components. I don't know what's wrong with me. There we go. We don't even need to say T. It's implied. Yeah, this is way better. Do that. We do that. We like, when we add a buffer, we just take care of the additional buffer stuff, and then we add the component. That's good. That's nice and clean. Then if the add component, implementation changes, we're still Gucci. We just need to update the value with the correct buffer ID and pass it along. All right, let's double check our create buffer ID system to make sure it works here. Oh, this buffers.add empty is something. We don't want to do that here. But we don't need to do that. What we do need to do is say buffer IDs dot add buffer ID. This is buffer ID dot index. Hold on, I've got two different maps. Probably call this the buffer ID map or something like that. I don't know. So we've got a buffer map and then we've got buffers, which are also happen to be a map. I don't love that. Got two different maps. This is the buffer ID map. That's why we called it the index map before, but we also call this the entity ID map. The map into the entity IDs. This is the actual buffers list. Call this, maybe we call this like buffer memory map. All right, so we've settled on that. We got a buffer ID system that maps to the actual buffers. We need to make sure that we're creating and destroying the buffers correctly. Content of a collection buffer ID map is only updated but never used. That's not right. Oh, we don't have a destroy buffer function. Or even a create buffer function, I guess, either. So we can just do a lot of this stuff. So when we create a buffer, we pass in anything? Just its type, right? Well, create buffer doesn't make sense outside of... No, add buffer is our function. Add buffer is the thing. What if we need to create a buffer and the entity doesn't exist yet? Like, what if we're creating an entity and we need to add a buffer? I guess we can make that part of this process. We need to iterate through the composition and see if any of the... We're going to need to say for each variable component in composition, for each component in the composition, we're going to need to say if component, is buffer. So if the component is the buffer, we need to we need a t value for adding a buffer, do we not? Only if we have a payload. If we do not yet have a payload, if we're just creating the entity, maybe it makes sense to have a create buffer function that makes an empty buffer and just reserves the spot. Just do that. If the component's a buffer, create the buffer. We need to pass in, do we need to pass in the entity ID? I want to increase the functionality of the create entity function. Because right now all it does is it reserves the slot for the entity ID, and that's it. Or no, it just reserves the slot in the archetype. So it reserves a space in all the chunks for this entity. In the same way, we need to reserve a space in the buffer. That implies that we need to set the buffer component, though. Can I do that if I don't know anything about it? Not really. That's actually a problem. How do we want to do that? I mean, I can come up with my own workflow where I like only do certain things. Like I'm very careful not to, like I know the order of like, well, if you create an entity, you then need to add its buffers. You can't just create the buffer as part of the entity or something like that. I could just add a check here and be like, creating an entity with buffers is not valid. But that's stupid. That's really stupid because that's like unnecessary entity movement. And if we eventually have like batch entity creation, we'd want something that supports that. Think you're gonna log off for the night? Good luck. Have a great weekend. Yeah, thank you, Scott. Yeah, I think I'm almost done too. I gotta go get some laundry going. But I appreciate that. Yeah, I hope you do. Hope you have a great one. And I appreciate you hanging out with us. Maybe we set the component for each of the buffers. Oh, pre-rolls are on. I'm snoozing these ads because we're wrapping up soon. Appreciate everyone hanging out this afternoon, though. I know it's been kind of a grind. But I swear, we're almost done with all this boring stuff. We're going to have ships. We're going to have little crew members running around the ships. It's going to be delightful. Don't get me started on pathfinding, though. That'll be a great test of our buffer system, pathfinding. Me working kind of oddly keeps you focused on working. Well, that's good. At least I provide some kind of value. All right. All right. So I think next time we're going to finish deciding how we want to initialize buffers when we create entities. We need a destroy buffer function. So we can make buffer IDs and recycle the buffer IDs, but we need a bit more clarity around constructing and recycling the buffers themselves, which is fine. Why? Oh, we need to pass in a buffer ID now. So it would be block comp dot buffer ID. I mean, any day where we start with no compiler errors and end with no compiler errors is a success in my book. But yeah, we'll finish. We'll hopefully finish up this tomorrow. I'll probably start a little late tomorrow. I'm having breakfast with a friend, which will be exciting, assuming I don't get blown away in the storm. Um, but yeah, we'll definitely be streaming tomorrow. So yeah, ship it. I wish I had time to do a raid. I should. Anytime we have an okay number of viewers here, I like to do a raid, but I gotta go get some laundry going, and I kind of waited too long. So thanks everyone for watching. I hope you have a great weekend, and I will see you next time. Let me get the music going. All right. Bye.